So now that we've talked about sequences and how to go from one term to the next term in an arithmetic sequence, we're going to talk about how to write it out as an algebraic expression. Because if you can describe how you go from one term to the next term to the next term, then, well, you can use algebra to write that out. Because if you can figure out what the next terms are, you can figure out what the nth term is. We'll talk about that, what that really means. So if we have a sequence of numbers, we're going to take something, we're going to take 2, 4, 6, 8, and 10. We're going to take those terms. We're going to think about how we go from one to the next. To go to 2 to 4 to 6 to 8, you are adding 2 to the next term. All right, so let's think, and each of these are terms. This is the first term, the second term, the third term, the fourth term. Okay, so if we can think about it like that, let's draw a chart to sort of represent what we have going on. And hopefully I can make this relatively straight. In the first column, we're going to put which number term it is. Middle column, we're going to describe how we got there, and then the last column is going to be what the value is. Okay, so in the first term, we can actually say it's 1 times 2 is equal to 2. That was Mr. Whitney sneezing. Okay, so the second term is the term that it is, so it's the second term, times 2. That's how we got that term. To find the third term, we take the 3 and we multiply it by 2 to get 6. Oh, wait. Clearly I messed up. This was supposed to be 4. Okay. The fourth term is 4. So 1, 2, 3, 4. So is 4 times 2 gives us 8. Is equal to 8. So this is the value. Now the fifth term, I think you might be catching on to what's going on, is 5 times 2 gives us 10. Now, what if I say, okay, we can figure out what the first 5 are. I bet we can figure out what the nth term is. So that is some number somewhere down in this sequence. Well, if you'll notice, these are all the same value as what the nth term is, or what the term number is. So n, and then these are all the same. That's 2. So n times 2, so we really write it, is 2n. And that's how to figure out the nth term. So if we wanted to figure out what the 20th term was, we would say 2 times 20 would be 40. If you counted that out, it would end up being, that would be the answer. So that's how you make this table to give you an algebraic expression for the sequence. All right, let's try another one. And I'm going to kind of grab the book because it's an example out of the book. So the book says, the greeting cards that Meredith makes are sold in boxes at a gift store. The first week, the store sold 5 boxes. Okay, so let's make a table. So the first week, that is the first value, first term. So the first week, the store sold 5 boxes. So we know that the value is 5. Each week, the store sells 5 more boxes. The pattern continues. What algebraic expression can be used to find the total number of boxes sold at the end of the 100th week. What is the total? Okay, so if they sell 5 more each week, this ends up being 1 times 5. If they sell 5 more the second week, so we're talking about the sequence looking like this: 5 the first week, 10 the second week, right, because 5 more, 15 the third week, because 5 more here, 20 the fourth week, right? 5 plus 5 is 10, 10 plus 5 is 15, 5 plus 15 is 20. So the second week, we take the value of the term, so the first term, this is the second term, and we multiply it by 5. We end up with 10. The third week, we take 3, and we multiply that by 5, right? Because here, you're adding 5 here. So this is the third term, so that's 5 times 3, and that gives you 15. The fourth week, same thing. Take the number of your sequence, multiply it by 5, you end up with 20. So the nth week ends up being n times 5, and again we traditionally write it as 5n. So that is the algebraic expression used to describe this sequence of numbers. Now the question here though is, what algebraic expression can be used to find the total number of boxes sold at the end of the 100th week? What is the total? So if we're going to say n is the 100th week, it would be 5 times 100, which would give us 500 boxes of greeting cards that they sold. Okay, that's how that table works. Okay, let's try the got it from the book. So the got it from the book says that there's this little pattern where figure 1 is 1, 2, 3 circles. Figure 2 is 1, 2, 3, 4, 5, 6 is 6 circles. So you've got your 3 original circles and then 3 more. So you have 6 circles. Figure 3 has 1, 2, 3, 4, 5, 6, 7, 8, 9. So it has 9 circles. 1, 2, 3, 4, 5, 6, 7, 8, 9. Kind of funny looking circles, but there they are. So figure 1 looks like this, figure 2 looks like that, and figure 3 looks like that. So if we were to draw a table to represent that, and we knew that our terms look like this. You have 3, and then you have 6, and then you have 9. So in the first week, we have, in the first figure, we have 1. Okay. In the first figure, we have 3 circles. Oh, I have a mouse for this. In the second figure, we have 6, and in the third figure, we have 9. Okay, so how do we get there? If we take the term number, and multiply it by 3, we end up with 3. So if we multiply 2 times 3, we get 6, and if you multiply 3 times 3, you get 9. So the nth term would be n times 3, and again it's traditionally written as 3n. And the question asks if the figure, how many circles will be in the 50th figure? So it is 3 times 50, and there will be 150 circles in the 50th figure. And that's how you do the got it.